All right, so let's start with this multiple choice section of the test. And here, the first question, they say that they find the correlation to negative 1.08. And I'm hoping that someplace in your mind, you say to yourself, correlation can't be above -1. It's always between 1 and -1, so something is wrong. So the answer here is D. They need to hire a new statistician. Okay, let's do number 2. Let's read this over. Here, do you see that SAT scores are Y, and my family income is my X. And then when they're done, they are going to say that the SAT scores becomes X, and the family income becomes Y. So they swap the axis. Okay, they swap the axis, and they want to know the slope. They want to know the slope. So look at what they gave us. They gave us R. Let me change my colors here. So they gave us the slope, and they gave us R, and that's about it. And they need to find the slope of the new line. Well, hopefully you remember that B1 is equal to R times the standard deviation of the Y divided by the standard deviation of the X. Okay, so keeping that in mind, let's set up our first problem. And I'm going to erase what is here because I need all the space that I can get, okay? And so we know my slope is 6.25 is equal to, my R is 0.48 times my standard deviation of Y divided by my standard deviation of X. Okay, so I'm gonna divide both sides by 0.48, and I get 13.02 is equal to the standard deviation of Y divided by the standard deviation of X. Okay, so that's the original setup. Now they swap the axis. They swap the axis. So now X becomes Y and Y becomes X. X becomes Y and Y becomes X. It becomes the reciprocal. If they swap places, we take the reciprocal. Now the way we denote reciprocals, maybe you talked about this in pre-cal, is to the -1 power, to the -1 power. Just like 2 to the -1 power is 1/2. 1/2 is the reciprocal of 2. So if I take the reciprocal on one side, I have to take the reciprocal of the other side. So if you look, I still have my 13.02 with all the decimals in my calculator, and hopefully you'll see at x to the -1 power. That is either called the inverse key or the reciprocal key. So I'm just going to press that, and I get 0.0768. Now this is equal to xx over sy, the reciprocal. All right, so now if I want to find the slope, do you agree I have to multiply both sides by r? But what is r? 0.48. So 0.48 times 0.768. So I'm going to take that number. I'm not going to truncate it or round it. I'll keep it in my calculator. Times 0.48. And I get 0.0368. Okay, so what's my answer? My answer is A. All right, I know I'm going to be doing that one before the test starts. Okay, 3. Let's go look at this one. The least square line of regressions have been fitted to a scatter plot. The residual plot is shown. Okay, so I look at that residual plot. I see that there's many dots above the horizontal. There's many dots below the horizontal. 2 dots look like they're on the horizontal. And do you agree with me? There's no pattern. There's no pattern. So it says the linear model is appropriate. Well, A is true, so let's go check all the others. The linear model is poor because some residuals are large. That is not true at all. The linear model is poor because the correlation is near zero. The residual plot does not tell us anything about the correlation. A curved model will be better. No, we don't go in there, none of the above. So the answer for 3 is also A. Okay, number 4. And what they want us to do is to find the correlation, to estimate it. If you take a bunch of fathers and you get their heights, and you take their heights of their 16-year-old sons. So that means that 16s are practically grown. Not fully grown, but practically grown. And do you agree with me that as the father's height increases, the son's height increases? So it's going to be a positive number. All right? So we know it's not going to be a negative. Hopefully you know it's not going to be near zero, right? Now we have near 0.7, exactly 1. Exactly 1 means that every son is going to be the same height as the father. That is not true. And we know that it can't be greater than 1 because we know that correlation is between plus or minus 1. So the answer is C. Okay, a good portion of them. Okay, so let's go look at this. The correlation between x and y is 0.35. So look what happens. They double the x. They decrease y by 0.2. They interchange the variables. They swap the axis. What's the new correlation? So hopefully you remember about the rules of correlation, about if the units change, correlation stays the same. And if you swap the axis, the correlation stays the same. So it's still going to be 0.35. Okay, so the researchers investigating the association between size and strength of muscles measure the forearm circumference of 20 teenage boys, and then they measure their strength and grips. The point to the lower right corner, about 1438, was removed. The correlation would become. Okay, so we called that point, that is not an outlier. It is not an outlier. But do you see, it is influential, because if I was to remove that point, what would happen to my correlation? I'm hoping that you say my correlation is going to get stronger, so the answer is B. Okay, let me just change temporarily to another color. So I changed to the color blue. Do you see that if I change that point right there, the blue point, that's really close to where the line is? Okay, the residual of that is really small. If I remove that, not much is going to happen. Do you agree with me? Because it's really close to the line. Okay, so here we're talking about a correlation of 0.6 at 0.6, and they said the speed of the barrier is 1.5 standard deviations above the mean. We expect the damage to be blank, the mean damage. Okay, so let's go see if the speed, what is speed? Is speed x or speed y? The audience crashed cars at speed z. They found a correlation between speed and damage. Okay, so hopefully that you agree with me that speed is the x. Right, depending on how fast you go, it depends on the damage. Okay, so we have to remember that slope is equal to r times the standard deviation of y times the standard deviation of x. And so if the barrier is 1.5, okay, so I drew a little picture of it. Remember I talked about this briefly. I drew a slope and I drew a little line going out and I labeled that sx and I go up and that's r times sy. Okay, so if xx is going to be 1.5, then this is going to be, r is going to be, was it 0.6 times 1.5? Okay, and that gives us 9. And do you see that because my x is above the mean, that my 9 is going to be above? So the answer is D. 8. Which of the following has a strong association but the correlation is near zero? Hopefully that you realize that's C because of the curved line. Okay, 9. Consumer report. Oh, the TV. Okay, so let's think about this. I know you guys don't go out buying this stuff, but how much is a TV? A TV was a $300, $200? And what size is your TV? So what size is your TV? I'm going to say 25 inches, okay? So I'm going to go take $300 divided by my size, which is 25, and I get 12. Okay, so which of these numbers is closer to 12? C. Do you see of all these numbers, that's the only one that has two places? Because this is 3 and this is 4. 4, 3, 2, 1, and 0. So because I got 2 decimal places to the tenths, that's why the answer is C. Okay, so here they give us this equation, and they say where y hat is the predicted weight and t is the age of the child. A 20-month-old child in this group has an actual weight of 25. So a 21 has a 20-month-old, and my y is going to be 25 pounds. And which of the following is residual? Okay, so hopefully remember that residual is truth minus predicted. So I know the truth, I just have to find the predicted. And how do I find the predicted? I plug x into my equation. So I'm going to go to my calculator, 16.6 plus 0.65 times 20. 16.6, help us out if I put the numbers in right, plus 0.65 times 20, and I get 29.6. So my truth is 25, my predicted is 29.6, and this is equal to negative 4.6. So my answer is B. Okay, you need to know how to do that problem. That's a good problem to know how to do. Okay, let's look at number 11 here. And they tell us that R, that's an R, is 0.72. So what does that mean? That the model can correctly predict the profit for 72% of the companies? No. On average, about 72 of the companies result from advertising? No. On average, companies spend about 72 on the... No. So the answer is A, none of this. Remember, correlation doesn't give us units. It just tells us the strength. All right? So I hope you found this useful. If you have any questions, come in for tutoring.